Hi everyone, our project is Chatbot for CS389.
So we created a chatbot for CS389 using retrieval augmented generation, hoping to provide more accurate and relevant responses for this class specifically. And we also hope that this large language model will be repurposed for other classes as well.
So for RAG, lectures audios are transcribed into lecture text using, and we also use semantic chunking technique to chunk them into smaller chunks. The Hugging Face BGA embeddings are calculated with each of the chunks and pushed into the vector database. The embeddings are also calculated for the questions query, and those questions are calculated compared to the vector database using cosine similarity, and we will get the first four retrieve context from that.
This slide just describes our different evaluations for retrieval methods we tried. We used TF-IDF, pre-trained embeddings, and then a combination between the two. And the evaluation that you're seeing here is using the Stanford question and answer data set, where I measured the accuracy of retrieving the correct context for a given question.
We also fine-tuned various LLMs. So we tried Llama 2 and Mistral, and we fine-tuned these on existing QA datasets, WikiQA and adversarial QA. We also had to use techniques to optimize resource usage, such as QLoRa and PEFT. And the training curves over 3 epochs, and as we see, Mistral 7b learns slightly better than Llama 2.
This chart just shows the evaluation of our responses. The first three are correctness, comprehensiveness, and readability, and these are generated by GPT-4 to evaluate our responses. F1 score is a measure between that measures the similarity between an expected response and the actual response we receive. And then semantic similarity just measures the semantic similarity between or expected response and the response received.
So for the demo, we're going to type a question here. While this loads, look at an example question.
This is just another example question we asked. What are some of the properties of a valid loss function? And as you can see, it highlights some key points that we talked about in class, such as having a minimum loss and being defined for all possible inputs and outputs.
Similarly, so our question about an autoencoder, it mentions encoder and decoder, describes these two aspects and describes as well the overall purpose of an autoencoder, which is a very helpful response.